Okay, let's take a look at while loops. Loops are a way for us to repeat code. These are called repetition structures. While loops will run as long as a certain condition is true. When I talk about a condition, think of if statements. They also, execute code based on a condition. They are condition controlled, which means that they have to have a true condition for it to work. They're what's called a pretest loop, which means that the condition is going to be checked before the loop runs. So it is possible that the loop doesn't run at all if the condition is not true. A couple of things we need to take a look at as we get into this is something called increment and decrement. Increment and decrement is increasing and decreasing an integer by a certain amount. In Java, we have a way to write a short form of something like this. So here we've got a variable I, which is an integer, and we're increasing it by 1. Or we could be decreasing it by 1. We have a short form way that we can write this. We can write I++, or we can write I minus minus. Mr. Jones, why would we do that? We're only saving 3 characters here. Well, you're going to find as we progress through loops is that we're going to do stuff like this a lot. We're going to be increasing and decreasing quite a bit. And so by 1, and using these, what I call counters, with our loops quite a bit. And so it makes sense to have a short form way with how much we're going to be using this. Here's a way that we can use this, how it might look in practice. Here we have a variable x equals 1. And then we have a variable y, which is being declared but not initialized. Here we have x++, which is an increment. And this is what's called a postfix because it's coming after the variable. Let me explain what this means. We have 2 things going on here. We have an assignment, which means we have x being assigned to y. So y is getting the value of x. And we have the increment. The question is which one's going to come first. And in this case, let's see if I can get this pen to work. In this case, we have x++. It's going to do, because this is a postfix, it's going to do the assignment first. And so here we have x began as a 1. So what's going to get assigned to y is that 1. It's going to do the assignment first. Then it's going to do the increment. So it's going to increment x to a 2. So when that code gets finished, y is 1, x is 2. The next case is called a prefix. This is where the increment comes, or the decrement comes before the variable. In this case, we're working left to right, and so it's going to do the increment first. So in this case, it's going to take x, which is now 2, and it's going to make it a 3. Then it's going to do the assignment, and it's going to assign that 3 to y. So by the end of all this code, we've got x and y both equaling 3. See if I can get rid of this, maybe. There we go. Okay, here's what a basic while loop would look like. We have a variable x equals 4. While x is greater than 0, well, x is 4, so it's greater than 0. I want you to do this stuff. That's what it's saying. So while it's greater than 4, let's print it, and then let's decrement it, or let's subtract 1 from it each time. And so what ends up happening is x is 4. It's going to check the condition. The condition is true. It's going to print it. It's going to make it a 3. It pops back up here to the condition, checks it again. It's a 3, so we're good. It goes back in the loop. It decreases it again, and so on and so on. It rinses and repeats. So what you end up getting is the first time through, it's going to print a 4. It's going to decrease it. It's going to print a 3, decrease it, print a 2, decrease it, print a 1. After it prints that 1, the x decreases to a 0. It goes back to the condition one last time. X is 0. It's not greater than 0. That's false, so it stops the loop. So basic loop, not a big deal. They do get a little crazier as we put more and more stuff in them. Something that we need to be concerned about is what's called an infinite loop. These are loops that don't have a way of exiting. In this case, we have the exact same while loop, except for Instead of subtracting 1 from x, we're adding 1 to x each time. And so x will never get an opportunity to be less than 0 or be 0 or less than 0. It'll always keep growing and never exit the loop. These are typically unintended results, and so we really need to be careful of these because it's usually not what we're wanting. Okay? I want to take a look at some common algorithms. I want you to keep these in your notes because we're going to use these quite a bit. We're going to use them on their own. We're going to combine them together. But these are just ones that we use quite often, and so I wanted to give you good examples. First off, what an algorithm is essentially a collection of code that performs an action, or it does a calculation. It does something really specific. And this is usually a combination of loops and decision structures and everything put together. It's usually not 1 or 2 lines of code. It's several lines of code. And so here we have an accumulation loop. You'll hear me say the word accumulator a lot. We'll talk about problems in class, and I'll go, okay, do we think we need to use an accumulator here or a counter here? Here's what an accumulator is. We got the same loop, x is 4, as long as x is greater than 0. Okay, so same thing going on. Except we have a variable called total. So what an accumulator is, it doesn't have to be called total, but an accumulator is a variable that can keep a tab on a total amount or keep and accumulate a total amount as a loop runs. And so in this case, we set the total. Typically, we're going to set that total to 0 so that it has a starting point. Inside the loop, we're going to accumulate something. This could be, in this case, it's just adding x each time. It could be that we're getting user input each time. It could be anything really, but it's going to keep grabbing more and more stuff every time the loop runs and accumulating it to get a total at the very end. And so in this case, it's going to keep adding x to that total. And if we remember up here, here's what x ended up being each time the loop ran. It was a 4, then it was a 3, a 2, and a 1. If I add all 4 of those up, that ends up being a 10. And so what ends up happening is the total becomes a 4 the first time, it adds 3 to it the next time, so it's a 7, then it adds a 2, it's a 9, and then it adds a 1 on the last loop to get a 10. And once it exits the loop, it prints out the total. Okay, a counter, on the other hand, works pretty much the same way, and it really is. You can see these are almost identical, except for a counter counts up by a specific amount each time. This counter is going to count up by 1 each time, and it can count how many times the loop runs for me. It doesn't have to count up by 1. A counter could count up by whatever. It could even count down by whatever each time, but it's a set amount every single time, whereas an accumulator may not be. In this case, the accumulator was a 4, then it added a 3, and then a 2, then a 1, so it was different every single time. So that's the difference between an accumulator and a counter. We can use these together, and there will be cases where we need both to do 2 separate jobs for us. And it all revolves around creating a new variable to do that job and then actually doing it inside the loop. Okay, the last thing I want to look at is input validation. This is really helpful, really beneficial. What this means is that we can now use a while loop to check if a user has put in a good data or not. So here I'm asking for a positive integer. I'm going to get that input, store it in num, and then I can use this while loop to check if num is a positive number. So while num is less than or equal to 0, meaning while it's 0 or it's a negative, probably the cleaning lady was coming in, I want it to keep asking the question. I don't want to accept it as a good number. So what I do is I'm going to repeat the question and ask for the input one more time. And it's very important that, a tip is you can just copy and paste this and then throw it in again back in the loop. But you want to edit it a little bit. You want to give them some input as to what's happening. So here I've added the words error so that they know that there's a problem. Because the user might be asking themselves, well, why am I getting asked the question again? And then make sure that you get the input again. You'll want to take off the declaration because you don't want to declare it twice. But this is super important. If you don't ask them for the number again or whatever it is, if you don't ask them again and give them a chance to exit that loop. If you leave that code out, you then have an infinite loop because num can never be a good number because you're never taking it back in. So that's while loops in a nutshell.